For any four sets A, B, C and D, if we take the intersection of the two sets, that is, one set is the Cartesian product of A and B and the other being the Cartesian product of C and D, then this is going to be equals to the Cartesian product between the intersection of A and C and the intersection of B and D. Okay, let us begin our proof. So first what we'll do, we'll have to consider an arbitrary element, and that arbitrary element is going to be represented by an ordered pair since we are working with Cartesian product. So let's let A comma B be the arbitrary element, with such that we are going to suppose that the ordered pair A comma B belongs to the Cartesian product of A and B intersection with the Cartesian product of C and D. This is an assumption we are considering. Now, what does it mean? This simply means that the ordered pair A comma B, since we have an intersection here, is going to belong to both of the two sets. That means the ordered pair A comma B must belong to the Cartesian product of A and B, and that same ordered pair A comma B, this must also belong to the other set, which is the Cartesian product of C and D. Now we're going to use our definition of the Cartesian product. If we say that an ordered pair A comma B belongs to the Cartesian product of A and B, that means that the first element of the ordered pair, which is A, this must be an element of the first set of the Cartesian product. That means A must belong to A. And the second element, which is B, the B must belong to the second set of the Cartesian product. That means B must belong to B. Similarly, for the ordered pair A comma B belonging to the Cartesian product of C and D, that means that A must be a member of the set C, and we have B belonging to the set D. Fine. Now what we'll do, we're going to rewrite this statement. We're going to rewrite this statement as A belonging to the set A and A belonging to the set C. And then we are going to have B belonging to the set B and B belonging to the set D. Now what does it mean? So here we are saying that we have an element A that belongs to both A and C, which means that A must belong to A and C. We're combining the statement now. And then we have the element B, which is a member of both B and D. In short, we can say that B must be a member of B and D. Fine. That means symbolically we can say A is a member of A intersection C and B is a member of B intersection D. Fine. Now, what we have? We can now use the definition of the ordered pair. So here we can combine this statement and rewrite it as A comma B belonging to, we have A intersection C, the Cartesian product with B intersection D. So what we are saying here is that A is a member of the first set, which is A intersection C. That is exactly what we have here. And B is a member of the second set, which is B intersection C. This is the definition of the ordered pair. If any ordered pair, this is the definition of a Cartesian product whenever an ordered pair is a member of it. So here we started out by considering an element A comma B, which is a member of the set, the Cartesian product of A and B intersection with the Cartesian product of C and D. So let's call it number 1. And then we obtain that same element also is a member of the intersection of A and C, Cartesian product with the intersection of B and D. So let this be number 2. So if we combine 1 and 2, this is a statement. This is the statement regarding the subset of a set. So from 1 and 2, what can we say? We can say that the set, which is the Cartesian product of A and B, intersection with the Cartesian product of C and D. So this particular set is going to be a subset of the set A intersection C, Cartesian product with B intersection D. We're going to label this as statement number 3. Fine. Okay. Now, next what we'll do, we will try to show that this right hand side, this set, this is also a subset of the set on the left hand side. Okay, so now we will be considering another arbitrary element. So let that arbitrary element be x comma y. So let x comma y belongs to the set A intersection C, the Cartesian product with B intersection D. Now when we apply the definition of the Cartesian product, that means that we have to consider the first element of the ordered pair, which is x in our case. X must be a member of the first set of the Cartesian product, and the first set is simply A intersection C. And we have to consider the second element of the ordered pair, which is y. So y must belong to B intersection D. Fine. Now x belonging to A intersection C, that simply means that x is an element that belongs to A as well as C. That means x belongs to A and x belongs to C. And then we have y belonging to B and D. So that means y belongs to the set B and we have y belonging to the set D. Fine. So what we can do now, furthermore, we can combine x and y. So here we can say x belongs to the set A and y belongs to the set B. We're only rewriting this statement. And then we have x belonging to the set C and we have y belonging to the set D. Okay, so this is going to be x comma y. This by definition is the ordered pair x comma y belonging to the Cartesian product of A and B. And then we have x comma y, the ordered pair. This is going to belong to the Cartesian product of C and D. Fine. So we have the same ordered pair which belongs to the Cartesian product of A and B as well as the Cartesian product of C and D. That means we can combine it and say that x comma y, this is going to be a member of the set, the Cartesian product of A and B intersection with the Cartesian product of C and D. So if we suppose this to be statement number 4, and finally we obtain statement number 5, which means that this set A intersection C, that simply, so we can write here that from statement number 4, from statement number 4 and statement number 5, we can say that A intersection C, the Cartesian product with B intersection D, this is a subset of the set, the Cartesian product of A and B intersection with the Cartesian product of C and D. So let this be statement number 6. Okay, so now finally what we'll do, we'll consider statement number 3, where we previously showed that Cartesian product on A and B intersection with the Cartesian product of C and D, that is a subset of A intersection C Cartesian product with B intersection D. And we showed the other way around, it's also true. So finally from statement number 3, and statement number 6, we can say that if we take A, the Cartesian product with the set B intersection with Cartesian product of C and D, this is going to be equals to A intersection C, the Cartesian product with B intersection D. Fine. Hence we have proved a statement.